All these all these projects are with people.
Yeah. Well, should we name our top 3, maybe?
Sure.
I kind of like the car colors thing. That could even be by state, maybe.
Yeah.
Like we could compare, or region, like you are what? Southwest, I'm Northwest.
Midwest.
Midwest, we don't have anybody to represent the East Coast.
We don't have to do. Well, because our hypothesis question could be the general. No matter what region of the country you're in, the majority of people drive red cars. And then the alternative could be, well, we think that people in blah, 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 blah.
Well, I bet there's some kind of statistic on favorite car color for the U.S.
Yeah.
And then we could just decide whether we're going to prove or disprove that hypothesis.
Yeah.
That sounds good.
So if we find some some kind of data on favorite car color,
Yeah.
then we could write our hypothesis from that.
That'd be good. Okay, and then the cereal one's fine too.
What's that?
The cereal one I thought was good too. Would you do
Yeah.
top, middle, bottom shelf?
Top, middle, or bottom shelf on the sugar cereal.
So we would just look at the sugar content on the top shelf and then compare it to the middle and the bottom shelf?
Yeah. The other one they did was whether there was a character on the front of the box, like something that would be attractive to kids.
Oh. That's interesting.
And
I have a stat here. It says since 2006, white has been the #1 car color in North America, and it increased another 6% in 2013.
Oh.
Wow, people are so boring.
So our question would be, in North America, the majority of people drive white cars. And the alternative would be people drive
The alternative,
cars different than white.
Yeah, just different than white.
not equal to.
Yeah.
Yeah.
That would be easy.
Well, I can say that because I drive a white car, so.
We have a gray and a blue.
I didn't choose it. It was handed down to me.
What
So
the?
I would probably choose red.
Maybe just drive around your neighborhood at the parked cars and see what cars in the driveway. You know what I mean?
Yeah. I like intersection though because I think that's more random. Okay, I'm seeing one.
Oh, yeah, like at a stoplight?
Yeah, I think that seems more random to me than like one neighborhood or something.
Yeah.
What's that noise?
I don't know.
My dog playing with her squeak toy.
Oh. Eloisa, are you there?
I'm here. Sorry, I'm have a little bit of roommate emergency, so.
Oh.
It's okay.
Okay.
Huh? I can't hear you guys.
Oh. We can hear you.
On
Can you hear me?
cars.com, they have
Yeah,
a
we can hear you.
Okay.
they have a color popularity report that's put out by DuPont Automotive,
Yeah.
and it shows white, black, silver, gray, red, blue, brown or beige, yellow, gold, green, or other, and it has the percentage.
Okay. What's percentage for white?
23%, the highest.
Okay. The one I'm looking at is from 2010, and that was 21%. So that's a pretty good.
Oh yeah,
indicator.
this is 2011, so.
Okay.
It was
But
still
white
pretty
is
close.
definitely, so it's around 20%, and it's white. That's a good. See what this one is. Oh, this one's clear up to 28% on white.
Oh, wow.
It doesn't have a year though. 2013 is 25%.
So what are we doing? Can I ask?
We're trying to decide on our study
Oh,
because we can't involve any people.
we can't involve people?
No,
No.
not at all.
Oh.
It's a bummer. So we've been discussing a possibility that we try to verify a favorite car color in the U.S.
There's already been studies about that though. It's red.
No.
Well, I'm sure the M&M thing's been done too. We're just students, so it doesn't matter. I'm sure the Chips Ahoy thing's been done 1,000 times at least.
Okay. Let's see.
Yeah, actually, so far we're finding that white is the most popular color.
Yeah. I'm on, I put in, what is the most popular car driven in 2015, and it says why white is the most popular car color, but drivers are ready for color. And this was posted in June 15th, 2015, but it doesn't have any.
Does it have a percentage?
No.
Hmm.
Here I found one on Wikipedia that does North America, Europe, Asia Pacific, and then world. And
Oh,
white
darn,
is on
we're
the
gonna have
top
to
there
take a
too.
European trip now to count cars.
But yeah, white leads on all of these too.
Okay. All right. So Eloise, this is what we've been talking about. Car color is one possibility. Another possibility is the location of sugar cereal in the cereal aisle. Like it's been shown to be down low, where the sugar cereal's down low where the kids can see it, kind of thing.
Mm-hmm.
And what else did we come up with, Christy?
What?
Skittles colors?
Oh yeah, our Skittles evenly distributed. That's kind of like M&M's, so colors evenly distributed. You could also do. I saw one with marshmallows and like Lucky Charms versus marshmallows in a generic brand.
Yeah.
Oh, we did the chicken noodle soup.
Oh, the chicken soup. That's right. We were gonna try and compare the chicken content. So we just need to decide on something.
And we want it to be, not too complicated.
How about almonds in a Hershey's bar and an almonds in a Symphony bar. I'm just kidding. I'm just kidding.
You just want an excuse to buy chocolate.
Yes, exactly. Yeah. Let's see. I always feel like M&M's always have blue and green M&M's and more blue and green than all the other colors.
You know another one I was thinking of, and maybe this is totally dumb. How many people put their Christmas decorations up before?
Well, BYU Idaho put them up today.
I drove around my neighborhood. I'm like, oh my gosh, people are already putting up their Christmas lights. Like, how many put the Christmas lights up before December? Oh my gosh.
Yeah, I thought the day after Thanksgiving was supposed to be the official day for that.
Yeah, so did I. Apparently BYU Idaho didn't think that was necessary. I was getting out of class last night at 10 p.m. and there were wreaths outside the building.
Wow.
Let's see. I don't know. We can do the Skittles one. It'd be simple. Or.
Well, okay, with something like that, exactly how are you supposed to conduct it? Like, how many bags do you have to buy? What?
You would only have to buy one, wouldn't you? Or we could all buy a bag. And
But is that a big enough? Is that a big enough sample size?
Well, wouldn't the sample size be the number of M&Ms in a bag, or the Skittles in a bag?
Yeah, I guess it could be. But then we only have to buy one bag between the four of us. I'll mail you all the blue ones, and I don't know.
Well, if we each bought a bag and we counted how many Skittles were in the bag, then we could just combine our totals and we'd have our sample size.
Yeah, we could.
Yeah, that's true.
How about pomegranate seeds? I'm just kidding.
Oh, I love it.
Me too. You probably grow them in your backyard, Christy, don't you?
No, but, you know, my friend used to have one in her yard.
Oh, that's awesome.
You should. They're expensive here.
Yeah, they are. Expensive here too.
What about the prices? I wonder if we can do anything like... There's always a Walmart around, so maybe we can compare prices between Walmarts.
Are they,
Well-
But I don't know how to do that properly.
I say we keep it simple.
Well, I like the car thing because I think we have a percentage to go on. Does the number of cars you see on the street match the statistic for favorite car color kind of thing?
We could.
Yeah.
Because that's a percentage, like that could be our hypothesis. Would it match 25%? That's the, I got, there was one that said 2013 was 25%. We could find a better verification of that number, but like just random cars on the street, would that match the national percentage of sales?
Yeah.
And then we
We're
could
going to do
just
North
like,
America.
yeah. And then maybe, like, how would we conduct the study? Just go sit in an intersection for half an hour or something? That'd be
Yeah.
scientific enough.
I think so because it's random.
Yeah.
very random. Maybe we could all pick like the same type of time of day so that
Okay.
it narrows it down a little bit more, so it's not, you know.
And we could say like a 2-lane, you know, like 2 lanes each way type size of intersection rather than 6 or something, you know, like a huge city.
Yeah. Yeah. If there's a place right by my house, I know where I'm gonna go sit.
Well, we've
All worked out.
roundabouts in Gig Harbor, so I'm gonna have to go find an intersection.
Oh. We're getting there. We're getting more of those.
It takes a while for people to learn.
Yeah.
Here,
People don't know how to use roundabouts here.
yeah.
Okay, so what do you think?
So
Should we take a vote? Candy, cars, or cereal? How's that?
I say
I like
cars.
cars. Yeah.
Okay, I think it's a little different probably than what most people might do.
Yeah.
Okay, so let's answer these questions. What is our research question?
The research question is,
Do the number
do
of
more
cars...
people drive... Oh.
Sorry.
Go ahead.
I'm just making a suggestion that we can modify it. So do the
Okay.
number of cars on the street reflect the national percentage for car sales of color? Something like that.
Shouldn't it have to be, say, it's either more than or less than or different?
Okay. Yeah.
So do the number of white cars?
What's that?
Are we going to say the number of, so do the number of white cars reflect
Yeah, just
the-
white cars. Yeah, you're right.
Okay.
Okay, so do the number of white cars on the street match the national percentage for white car sales? Does that sound?
Match
Is the percentage of white cars,
or
because you said the number of white cars, so the percentage of white cars in the street is equal to,
the
or is different than the national percentage of
white cars driven.
Mm-hmm. We all have to turn this individually, don't we?
I don't. How do we assign it individually and turn it in?
Yeah, it's an assignment to turn it in. The group leader's supposed to turn it in, but it has to be everybody. Everybody has to agree on this.
Okay.
Okay, so do the number of white cars on the street match the what?
The percentage of white cars.
We need to say percentage because we're going to go by a percentage. So is the percentage of white cars on the street different than the national average for sales?
Percentage of white car. You have to say
National percentage of white car sales.
Sure. That sounds good to me.
Okay, so is the percentage of white cars on the street different than the national percentage of white car sales? Does that sound right?
In America. In America? In Northern America?
In North America.
Northern America. Okay.
Wait, are we all on the West Coast or where are we at? Where are you guys at?
I'm on the West Coast.
I'm on the South.
You're in Arizona, right?
She's Southwest. Shannon is Midwest.
Midwest.
Okay, I'm in Idaho.
So
Yeah,
I think we
have
could.
nothing. Okay, because I was gonna say maybe we can say the West Coast, but we not technically all in the West Coast, so we're fine. National average should be fine.
So, but should we say something like the number of white cars on the street match the national average of they both need to be color related, like most popular color of car driven in the United States or in North America?
Well, I think that's where we have to clarify the statistic. Is it just car sales? Is it manufactured? Is it opinion poll? What's the most popular color? Something like that. We need to. I think sales is good because that's probably what
Right.
they're counting.
Yeah.
So we'd have to make sure the percentage is actually sales,
Okay.
and then we could adjust it.
National average. So we're saying is equal to, and then our alternative would be is different. The number of white cars on the street is equal to the national average of sales of white cars in North America.
Well, I was thinking we could just say, is the percentage different than the national? Because that's all we have to prove is different.
Okay.
Not. We could do less or more. Do we think it's more white cars or less white cars? Because I don't know. I don't see that many white cars around. So
what's the percentage? Do you know? Do you have that in front of
the
you?
last time, the latest one I saw was 2013, and it was 25%.
I have no idea.
I think that's about right.
So when we're observing, we'd have to see 25% of the cars would be white, or we would just reject the. Oh, so does our research question doesn't have to match the hypot? Wait a minute.
I know.
Does it match our research question would match the alternative hypothesis, wouldn't it?
Yes, that's what it would be.
Yeah. So that's why we want to say, is it different than the national percentage?
Okay. So the number of white cars on the street, or the number of white cars on the street different than the national percentage of white cars sold?
Yeah.
National percentage of white cars sold in North America. Or we could just say the United States. Okay, that's good.
All right, so the null would be P equals 25%, or 0.5. And the alternative?
You have to say, wait. What are you saying for your no?
That P equals 0.25 or 25%.
Don't you have to say like the full sentence? Or like the national value or the national percentage of white cars sold is 25%? Because if you just say P equals 25, like with that, I don't know.
We would have to put the 25 in the research question, wouldn't we? So then instead of just saying different than the national average or national percent, we could put the national.
We could say different than the 25% national average of white car sales.
Yeah.
Yeah.
So what population are we studying? Is white cars on the street?
Yeah.
Yes.
Or just cars on the street?
So here's the thing. I think we're gonna have to find something different than what is it the deal with my screen?
You keep changing color.
Well, anyway, I keep thinking of the term that there's an actual term where you start like saying things like that besides hallucinating.
Maybe it should be, is the proportion of white cars on the street? Is that what you're talking about?
I forgot what I'm talking about. What the green threw me off. What were you saying, Renee? You were saying something. I can't remember.
What population are we studying?
Oh. No, I was beginning to think of the data. So I don't think if we sit in an intersection, cars might come faster than we.
You could have somebody with you. They could count the colored cars, and you could count the white ones.
Yeah, and then we could do it for a certain amount of time. We could do it for like an hour.
Yeah.
Yeah.
Or we could just do like the ones that actually pass us by, not the, if you start counting like cars that are stopped at the intersection, that might be.
Well, if you go to a stoplight, you're gonna.
Yeah,
stop.
I'm just thinking if you just count the ones that are going past you.
Right.
Like if you're stopped at a certain point, they come through the intersection and they pass you, and you count them that way.
Wouldn't it be
like 2 lanes?
Just go to a random, like a Walmart parking lot?
And drive up and down the aisle.
And it would have to be Walmart, people that shop at Walmart, what color cars do they drive?
Yeah, that's true.
Okay, good point.
Because I think the intersection is more random.
Yeah.
Say what the?
Now you're lovely pale yellow.
Okay. So our population is white cars, right?
Yes.
Okay, white cars.
Yeah, we need Doug. Doug the dog to count cars for us.
I think laughing at the fact that it's like switching screens. Hey,
Hey, you're almost normal there for a minute.
So we'd say the national value of white cars sold is 25%, and then the alternative would be the national value of white cars sold is different than 25%, right?
yes.
And that would be it, right?
Wouldn't it be not equal to 25%?
Yeah, different and not equal are the same, mean the same.
Well, you have to, so you're saying we have to do it both ways. We have to just write up the P equals whatever, and we have to write it out.
Well,
As well.
Sure.
Okay, so tell me what you said.
So I said the national value of white cars sold is 25%. And then I said the national value of white cars sold is different than 25%. So we could do less than, greater than, but if we do different, we just have to do a two-tailed thing.
Okay. Well, what I can do is I'm going to take all your suggestions and I can type this up and I'll email it to everybody. And you can give suggestions or approve it before we submit it, because we don't have to submit this till Saturday, right?
Yeah.
So I'll email it to everybody so we can look at it and change whatever. And I don't know how we're supposed to sign it.
I know.
I'm just going to list everybody's names again. she can tell us if there's some. I'm not doing some online signing thing. That's a little complicated.
Yeah. Do you want to go over to design the sample, or do you want to do that first?
Yeah, so what would it be? Would we consider it a cluster sample? Because we're each in a different state.
But you're not doing everything from that state.
I
Yeah.
would say it's just a simple random sample.
I think so too.
Okay. All right.
Okay, let me describe how we'll gather the data.
Okay, well, I'll just write that up, and then you guys can see it before I submit it,
Okay.
and you can give me suggestions. I'll try and get this all done tonight and email it to you, and then you can read it and give me suggestions.
Okay. That sounds
All right. Okay.
Yay!
Hopefully we'll get accepted. We won't have to start over.
I know. I hope not. Okay.
All right, we have a math lesson to get to here at some point.
Sure. Whatever. I love math. Say it.
No sarcasm.
Oh, well, I won't tell you what I did today then.
What?
I told my son I could prove to him that math is evil.
Oh!
Oh, I know what you did.
Because in the formula it says officially x equals the number of successes
Uh-huh.
and n equals the number of trials. Well, that one
Uh-huh.
problem we did was x was death. Number of successes, then x is death, and that's kind of evil.
You know, we should prove this for our statistics project.
There you go. How many math questions are evil? Uh-oh, we lost Eloisa again.
Oh.
No, I'm here. I'm
here.
Oh, okay.
All right.
Trying to figure out this weird screen thing.
Well, it's not bothering us, so
Yeah.
Hey!
Oh, there you go.
if it doesn't bother you.
Yay. You're just a little blurry now. Oh, there you go.
Oh.
Oh. I think one of these times we should all wear a mask. Or put on a funny face or something. Wear wigs.
There you go. We missed Halloween, dang it.
Let's do this.
Okay, I'm ready.
Are
I
you?
mean, not really, but yes, I am. Did everybody do okay on their first individual prep assignment?
Yeah, I did okay.
Okay is keyword.
Yeah.
You know what I really love though is the Excel thing. Did
I
you guys
know.
do that?
Where has that been all our life? You just put in the two numbers and you get everything you want, right?
I know. So awesome. So I recommend that for the homework. Just make sure you pull that up.
Okay, I'm doing that right now.
Okay.
What is it with the screen? Sorry.
Okay, has everybody got their quiz open?
Yes.
Yes.
Okay, so number 3, the symbol for true population proportion is the p-hat, the first one, right?
Yes.
Yep.
Somebody want to read number 4?
The requirements for constructing a confidence interval are satisfied if n equals 100, p equals 0.25, and p hat equals 0.10. So I think we just have to plug into that formula. N p hat is less than or greater than 10, right? And then n parentheses 1 minus p hat is less than or greater than 10.
Yeah. Do we have everything we need to do that, right?
Yeah.
So n times p. Yeah. Okay.
Right? Are we all following along?
Yes.
Okay. I mean, we probably could just do it in our heads.
Well, n times p is 25, so that's above.
Yeah.
What's the other one?
The other one is
Minus p. That's
Sorry, we're wrong on the P thing, on number 3.
It's just regular p?
It's just regular P.
Okay. So the p hat is the population proportion, and p is the true population proportion.
proportion.
Yeah.
And that makes sense.
Okay, so question number 4 is the requirements for constructing a confidence interval satisfied, and we said true.
True.
Well, the first one I did so far was true. Did you get the second one, Christy?
Almost. Yeah. 75.
It's 75.
Yeah. Okay.
Yeah.
So they're both greater than 10.
Okay.
Yeah.
So that's true.
Right. And that would mean the hypothesis tests are also satisfied. Right?
I'm checking that.
So step 2 for the hypothesis test was you have to check the formulas.
Say that again.
Step 2, so it says if we follow the conditions are satisfied. So it's the same formula for the hypothesis test, I think. It's on page 6 under step 4.
Okay.
Do you guys agree?
Yeah, I think so.
Okay.
So 4 and 5 are both true.
Yeah, I think.
Okay.
Yes, they are.
Yeah.
Way to be confident.
We
Thank
are confident.
Yeah, we are. Okay.
Okay.
Number 6.
Yeah.
A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. So we need to find the p-hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state.
Okay. You guys know how to do that one?
So we can use the sample, the Excel sample test, right?
Or can't you just divide 45 by 60?
Yeah, I was gonna say I thought it was X over N.
I think that's like our easiest formula when they ask for that.
As long as you have X and N, yeah.
Well, we did.
The wrong way.
Huh?
I don't know. I'm suspicious.
I'm not. Don't be suspicious. Have some faith.
Coming from the person that freaks out every time we move.
What?
No, nothing. I was kidding.
Down to 3 decimals. Okay, so we got 0.750, right?
Yep.
Okay, so we can put these numbers into Excel, the 45 and 60, right?
Yeah.
So what do you all do for the null hypothesis when they don't give it to you?
I don't think I put it in. I think
You just ignore it, or what?
um,
Because sometimes you have to put it in, and other times it doesn't seem to matter.
yeah, I just put in the confidence level, and then I don't put in the null hypothesis. I leave blank.
Yeah, you just leave them. You just put in X and N in the confidence level.
Yeah.
All right. So we're looking for
The confidence interval.
Okay, so I got the second one.
Me too.
so 0.640
Yeah.
to 0.860.
Yep.
Where did you guys get the Excel sheet from?
It
It was in the lesson, wasn't it?
it was in
Yeah.
the lesson,
I looked
but
for
it just takes you to that first page, didn't it?
Yeah, I cannot find it in like the regular Excel or SPSS. So I just downloaded it before I opened up the quiz.
Oh, yeah, because I opened a different. Let's see. Is it on there? Oh, wrong lesson. Duh. That's embarrassing. Yeah, it's not a link.
I couldn't make it work at first, but then I found, I don't remember what I did. I haven't closed it out since.
Yeah.
Yeah, because I've opened the lesson like tons of times and it still won't come up. La la la.
Okay, are we moving on or?
Yeah, keep going. I'm trying to figure it out.
Okay, number 8.
Here, I'll read it if you want.
Okay, go ahead.
If you increase the sample size from 60 to 80, what do you expect to happen in the width of the confidence interval? So, wouldn't you...
Doesn't it get smaller when the
That's
sample
what
size goes
think
up?
that's what I was going to say. It would decrease.
I actually tested it. I stuck in 80 for instead, and
Yeah.
it does actually, the width decreases. It goes down to 0.126 between the two numbers
So smart.
instead of 0.20. Well, 0.640 to 0.860 is 0.22, and then the numbers go down if you put in 80 for a sample size.
Good idea. I like that. I like that a lot. Okay. Let me do the next one.
Yep.
To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose p equals 1/2. What is the smallest n can be, and both requirements still be met? Okay, this is where we solved for n last time, right? With the greater than or equal to 10 formulas.
Okay.
So I'm getting 20.
That's what I think.
So the smallest n can be meet both requirements.
Okay, how do you figure that out? This one always gets me.
Okay, so I'm using the n p hat is greater than or less than 10 formula, and then I'm doing n, and then I'm doing times 0.5 because p is 0.5, right?
Yeah.
Not p hat. Sorry, I said the wrong thing. I shouldn't be p hat. Okay. And then, so you multiply n times 0.5 and you get 0.5n, but you want to get n by itself. So you're going to divide 0.5 from the n 0.5, and you're going to divide both sides. So you divide 0.5 by 0.5, and then you divide 10 by 0.5.
Okay.
And then you get n equals, or n is less than or greater than or equal to 20.
Yeah.
Did you get it?
Yep.
And then I also did it for the second one that they gave us, and I came up with the same answer. The n parentheses 1 minus p formula. So I got 20 on both.
Yeah, I got 20 on both of them as well.
Okay. All right, guys, we're halfway there. This is the same question.
So we'll just do the same thing, but use.
Yeah.
Yeah, it's 1/10 instead of 1/2.
Yeah. So that'd be 100, right?
Yep. That's what I got.
What, did you guys get 100?
Yes.
Okay. Are we moving on?
Sure thing.
Yeah. All right. For questions 11 through 16, use the following information. For the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level A equals 0.05 with the following hypotheses. The null is P equals 0.6, and the alternative is P is less than 0.6. They collect new data in this time N equals 80 and X equals 38 indicate good health. So it says the conditions for conducting a hypothesis test are satisfied.
So this one we could put the 60% into the null and put in our numbers for X.
I can't hear you, Christy.
Okay, so this one we would use Excel, and we would put the 38 in X, in the X position, and the 80 in the N position, and then you can also put in the 60% for the null hypothesis, right?
And then less than? Is that what you did?
Yeah. And then it looks like they both meet the requirements.
Yeah, it looks like it does.
Yeah, so 40, 48, 32, 36, and 44, they're all, the hypothesis test and the confidence interval test are all above 10.
Yeah.
Mm.
And then we just have to look for the p-hat for the next question, which is already in Excel.
Is it 0.475?
0.633.
Mine
Mine
says 0.475 as well.
What?
Oh my gosh, how is this possible? I have 0.450.
This is
Did you
terrible.
put it- Okay, let me look at the question here.
Did you guys change the null hypothesis to 0.60?
Yeah, I did. Mine says on my inputs I have X equals 36, N is 80.
Oh, it's 38.
Oh, it's 38. Okay.
Did I say 36? I probably did.
I don't know. I didn't. I guess I didn't even look at the problem.
So we have. Okay, so 38 and 80, 90%, 95% confidence. Null is 6.
0.60,
Yeah.
and then less than.
Less than. And I have 0.633.
Bless you. Bless you.
It's my roommate.
And that's under the p-hat in descriptive statistics?
Yeah, it just says p-hat.
Yeah.
Now.
Yeah, and mine says 0.475.
So does mine.
So does mine.
What the heck? That is so weird. Why does mine not say that? I have the exact numbers. What does your hypothesis test requirement say?
Hang on just a second.
Mine says 48.000 and 32.000.
That's what mine says too.
Mine doesn't.
Did you put a percent in? Did you put 0.95 in the confidence level?
It was already in there. I didn't change it.
and 0.60 for the null hypothesis.
Yeah. I just highlighted the 0.60 and it changed it. Okay, I got it.
Okay.
Thank you. I was like, what's going on? I have all the numbers in here. Okay. Okay, good.
Okay, so we got 0.475 for
Yeah.
the p-hat. Okay.
Okay, the z-score.
I have negative 2.282.
That's what I have.
Yep.
That's what I have.
I have that too. Okay.
And it wants to know the p-value. I have 0.011.
That's what I have.
Did you put it in the probability app, or are you just looking at the?
I'm just looking in Excel.
I'm gonna double check it.
Should we try it?
And see if that's, yeah. I'm sure it's right. And you have 0.011?
0.011. Yep, that's what I have.
Yep. Yay. Right. So we're going to
We're going to reject the null.
check. Reject. Okay, so there's sufficient evidence to conclude that the water quality in the area has decreased, right?
Yeah. Well, which one did you say?
There is sufficient evidence to conclude that water quality in the area has decreased.
Yes, that's what I would say.
That's the first one, right?
Yeah. Because you only use insufficient if you reject the null. I mean, if you fail to reject, right?
Yeah.
Okay.
Okay, sounds good. So we
Alright,
good on
guys.
all the other ones? No.
Huh? I think that's it.
Okay, I'm just double checking I answered everything.
And I didn't add too many decimals. I did that. It's so irritating. Okay, I'm gonna submit mine. You guys want me to?
Why not?
Okay. Hey. Yay, 100!
It was 100?
Yep.
So both the requirements for the first 4 and 5 were true, right?
Let me look at the details.
Yes.
The confidence interval and the hypothesis test, yeah, they're both true.
Yeah.
Okay.